Okay, I wanted to do a demonstration to show how the stars are travelling north to south. For an example, if we're looking down this hallway and I'm to the north, to the other end of this hallway is to the south, and from one side of the hallway is east to west. Okay, so going across the hallway like this is east-west. Well, to go down the hallway would be from north to south. So basically, the stars, to go north to south, they have to go down that hallway away from me to go down. Then they go back from west to east, then from south to north, then from east to west. If they were just going east-west, they'd be going in a straight line straight across. They would not be going away from me. Okay, that's how depth works. It's like when you do a time lapse, it looks like two-dimensional, like that red circle without any background. It just looks like a two-dimensional circle. Well, it's actually going away from you and around. It goes north-south, west to east, south to north, back from east to west. That's how it's actually making its circle. You can't make a circle unless it goes north to south. Same with the converging line. For an example, if you were to follow these lines all the way down the hallway, well, these lights will actually diverge and go below the horizon and end up below the horizon. That's how why we don't see the Polaris star, is because even though these parallel lines, they converge, one goes up, one comes down, and it converges to a point until it starts to diverge and go down, like basically why Polaris is why we can't see it. Even though it's a parallel line, it will diverge at the point of convergence. I have many things to show. Where are we? In here. I even done another one out the back of the lights, of how they converge down. And for this red light to go around this white light, it has to go away from me. It's not looking like a two-dimensional circle, it's in 3 dimensions, it's got depth, it is actually going this way, away from me, which would be from north to south. Then it goes from west to east, back from south to north, then from east to west, and that's basically why it is going north to south. And the star itself is almost 90 degrees above my head, so it's basically up here and going down to, I don't know, almost 45 degrees before it starts bending around in that star photo, which means it's going from north to south. Yeah. Okay, I just wanted to make a video to show how parallel lines converge. Basically, this top section of the veranda is parallel to this ground. You can measure the ground from the top of this pergola to the ground on this end, and you can measure it at that end. It's the same distance. Well, what happens if you're level with the light bulbs, they don't angle very much because you're at that same parallel line. But if you come down in depth, the angle to those lights are changing, and the further they go down, the more angle they are. So the higher something is, the more it angles. And that's just a basic quick demonstration on how height changes the angle, and same with distance. The depth of how far something is changes the angle to how you see it. As well as if you were to spin these stars around, so where that white light is at the very end, and you were to spin this parallel beam so it was on the other end, it would actually go lower than what that last light is. It would actually go down to the converging line and hit the horizon. That's basically how depth works. Yeah. What I want to show is how parallel lines, two lines that are perfectly level, like how I showed in the hallway picture, these lines are parallel. This line here is parallel with this one here. Why is it that we see these two parallel lines converge together? It's because we have depth. It's not two dimensionals. You have to think in 3 dimensions. Well, there's more than 3 dimensions, but anyway. And for an example, the higher something is, for an example, when we look at clouds, clouds are more at this height. So then therefore the angle away from you is a lot less. The higher something goes up, which I explain in a video, that the more it angles down, and you'll see that in my other video of my lights. But yeah, this is what we're actually looking at, and the stars are doing a 45. That's because it's perspective, is what we see. The convergence, how it converges down, which is like how the roof converges down. And if that roof was higher, that angle would be sharper. It would actually go right down, like it's like you're looking at a 2-dimensional wall. But yeah, what I wanted to show about vertical, as to how I mean vertical from the poles, the stars aren't vertically spinning at the tops of the poles, millions of miles away from Earth, because there'd be a void from here to here where we wouldn't see stars. The stars circle and meet at the equator, so the southern pole stars are going around in a circle, but they meet the northern pole stars at the equator. And what I mean by that is this: the stars are spinning like this, horizontal to the plane, and this is the north, this is the south, and they meet at the equator. They're not spinning vertically at the poles, because if they were spinning vertically at the poles, you wouldn't have stars at the equator. Same with how I've done my diagrams. The stars spin like I just showed you in that picture, but this is an above view from the stars. This is all mapped out exactly how it all works from above, from the south to the north, how they meet at the equator. You can map out every star that's on here, the Southern Cross spinning around here all the way out to the stars spinning around at the equator. Yeah, the sun time zones, why we get 14 hours of sun in the summertime, why we get 12 in spring, 12 in autumn and 10 in winter. I'd like to see time zones written up on a ball, because that would be very interesting. I can show time zones exactly match why we get the time zones that we get with this diagram, but it'd be interesting to see how time zones are made on a ball. Yeah, there are many things that I look at with even dimensions. I mean, this is how we see things. We see things like this. This isn't 3 dimensions. It doesn't look 3 dimensions. Well, it doesn't look like the 3 dimensions that we look at, which is basically like this. They don't look anything alike. Everything converges to a point. That's why planes disappear in the sky, because they get that small the further they go, and then all of a sudden you cannot see that plane anymore. Where if you were looking in this dimension, that plane you could see forever. Yeah, but this is the dimension I believe we live in. Yeah, a very weird, sophisticated dimension. It's straight lines and circles. But yeah, anyway, what I can't seem to wrap my head around is the moon and the sun travel from east to west, but where I am, the star travels in this direction. That's what I can't seem to wrap my head around. Because if the Earth was spinning from west to east, so the moon goes from east to west, how can this star be going in this direction? That's what's got me really confused. And what I mean by that, on my map, the moon goes from Tropic of Capricorn to the Tropic of Cancer in 28 days. So basically it's going back and forth in 28 days. Okay? But the sun does this in 6 months. That's another thing that confuses me. I don't know what the moon is going up and down on the side of the ball, or how does that work? But what I'm basically saying is, when the moon goes onto the other side to the northern hemisphere, and the moon is coming around from the northeast, that's where it rises, then it tracks around. But what's going on is this star is coming from here, going north to south, because I'm roughly around here is where Australia is, and I'm watching that star track around here north to south. So yeah, there's a lot of interesting things that I look at. Thanks for watching.